Oh, hey, algebra, ladies and gents. Today is Wednesday. We are doing a graphing review today. I know that graphing yesterday was a little difficult for some of you, and there might just be a couple things that we want to practice and go over, and so we're going to spend some time doing that today. I've got 4 graphs for you that we're going to go over. And so we're just going to make sure that you know Thursday and Friday is going to be the review over all of Chapter 10, Sections 1, 2, and 3. And then Monday you have your test. Now remember, use your notes, guys. You've got everything right there for you. So go ahead and use your notes and what you need to do. Okay, so the first equation is y equals the square root of x plus 5. Now there's 2 ways we can look at this. Now remember, you could do, the first thing that you could do is you could find the vertex. Or that's like the starting point. Now remember, to find the vertex, you have to use what's inside the square root after the x. So that would be the h. So y equals, we've got the square root of ax plus h minus k. So we could do the opposite of what's inside of here and then the k. Or we can just make it equal to 0. So what I like to do is I like to find my 5 values first. And I go ahead and find what gets that square root equal to 0. Because I want to start with 0. 0 is the first thing I want to work for. And if I plug in 0, that actually gives me 0 plus 5, which would be 5. So my ordered pair would be 0, 5. That is my vertex. That is my first ordered pair. And if I go to my graph over 0, up 5, that is going to be the first point on my graph. Now you notice, since it's a positive graph, it is going to go up. Remember, it's like a half of a sideways parabola is what we're working with. So now the numbers I want to get under the square root are 0, 1, 4, 9, and 16. And really, we don't have to do 16 because it's such a large number. So 0, 1, 4, and 9 are what we want to get underneath the square root to equal. And in order to do that, because those are my perfect squares, I need to see what I can plug in. Well, in this case, it's actually really easy because it's just x. So I can just do 1, 4, and 9. And if I plug those in, I do the square root of 1 plus 5. Well, the square root of 1 is 1 plus 5 is 6. So my next ordered pair is 1, 6. The square root of 4 is 2 plus 5, which would be 7. So my next ordered pair is 4, 7. And the square root of 9 is 3 plus 5 would be 8. And so my next one is 9, 8. Now remember, you're going to start to see a pattern. 5, 6, 7, 8. As long as you're plugging in the perfect squares, because this is the square root of 0, this is the square root of 1, this is the square root of 2, this is the square root of 3, so they're going up in a linear fashion. If I plug in 1, 6, that's next. If I plug in 4, 7, that's next. And if I plug in 9, doesn't quite fit, but it's going to be over here, that's going to go up as well. Okay, so next we're going to talk about the domain and the range. Now your domain and your range are actually going to use your vertex. Since it's going up and to the right, they're actually both x is greater than or equal to 0 and y is greater than or equal to 5. Now remember, 0 is where the x-axis stops. That's why it's 0. And 5 is where the y-axis stops, so that's why it's 5 that way. Okay, 3 more to go. In this one, we have an added minus 2 at the end, and I've got an additional thing happening underneath my square root, underneath my radical. So remember, the numbers I'm looking for are 0, 1, 4, and 9, because they're all the perfect squares. So in order to get this number under here equal to 0, I've got to figure out what I can plug in. Well, in this case, I can plug in a negative 1. That's going to give me my vertex, right? Because it's the opposite of this. And then imagine it might just be negative 2. Let's plug it in and see. So I've got the square root of a negative 1 plus 1, which is 0, which is then minus 2, would be negative 2. So my first ordered pair is negative 1, negative 2, which is also my vertex, which is my first point. Negative 1, negative 2, plot that point. Okay, since it is positive and positive, it's probably going to go up just like this. We'll wait and see. Okay, how do I get it to 1? Well, I'm going to get 0 plus 1 is 1. How do I get this inside number to 4? I'm going to do 3 plus 1 is 4, and 8 plus 1 is 9. Now I just need to solve. So the square root of 0 plus 1, that's 1, minus 2. So the square root of 1 minus 2 would be a negative 1. Again, you're going to see a pattern. And then I do the square root of 3 plus 1. So that's 4, which is 2, minus 2, which is 0. It still follows our pattern. The next one is the square root of 8 plus 1, which is 9, which is 3. So 3 minus 2 would be 1. All right, so you see how it's following the pattern along there, and that's exactly what we need to do. So I'm going to do my next ordered pair, which is 0, negative 1, over 0, down 1. The next one is 3, 0, so over 3, up 0, and 8, which doesn't fit on my graph. It's going to be like right over here. So it is going to go up. Let's talk this time about my domain and my range. So my domain, and remember I'm going to use my vertex for my domain and my range. So my domain is x, because that's what I plug in, is everything greater than or equal to negative 1. And my range is my y, because that's what I get, is everything greater than or equal to negative 2. All right. What's different about this is there's a negative 2 out front. When it's a negative, it means it's going to go down, and it also means that my range is going to change a little bit. So again, the numbers I want to plug in are 0, 1, 4, and 9. Okay, so let's plug in, how do I get underneath here equal to 0? Well, if I plug in a negative 2, that would very well get that equal to 0, and that's going to give me my vertex. So I've got a negative 2 plus 2, which would be 0, and then I need to take that times my negative 2 out front. So the negative 2 times 0 is just 0, which gives me the vertex of negative 2, 0. Again, there's nothing on the end of the vertex, so that would also be my indication that that's 0. So negative 2, 0. The next one I want to get to is 1. So how do I get this 1? I'm going to plug in a negative 1. I'm going to plug my negative 2 out front so I don't forget it this time. The square root of a negative 1 plus 2 would be 1. So 1 times a negative 2 would be a negative 2. Now you're still going to see a pattern here, but since there's a number out front, it's actually being multiplied by that number, not added or subtracted. All right, now I need to get to 4. So what plus 2 is 4? Well, that would be 2. So it's negative 2, and I'm going to end up with the square root of 4. All right, so the square root of 4 is 2 times the negative 2 would be a negative 4. See the pattern? And you're guessing, guess what that last one's going to be? If I get 9, that would be a 7. So a negative 2 times the square root of 9. That would be 3. That would be a negative 6. So I would have, 2, negative 4, and 7, negative 6. Okay, let's graph this bad boy. Negative 1, negative 2. Oh, look, it's going down. 2, negative 4, and 7, negative 6. Now, what's going to happen is this is a lot larger, so it does increase more dramatically on the bottom because you're multiplying by 2 instead of just going by 1 every time. It is going down, which means that my domain, the x stays the same. The x is, since it's always going to the right, it's going to be anything that's greater than or equal to negative 2. And then my range, that's my y value. This time it's actually going to be less than or equal to 0. Okay, so I'm still using my x and y values, but since the range is going down, it's going to be less than. All right, last one. Here we go. All right, the last graph that we have on here, this has a lot going on. So this one has a number out front, and it's got a number at the end. So what you're going to find is we could find the vertex right away. Okay, your vertex, remember, is going to be the opposite of what's in here. So it's going to be 2, and then it's going to be negative 1 because it's whatever is on the end. Now, you're going to be able to see this is going to be my starting point, and that's fine. And since it's a positive number, we know that it's going to go up and over. But I need to figure out what numbers I'm going to plug in. So we know that 2 is the first number I'm going to plug in. Now, if I go and I plug in 2, that's going to give me 4 times the square root of 0, which is 0, minus 1, which is going to give me a negative 1. So my ordered pair is 2, negative 1. That's my vertex. The next number I want to plug in is I want to get this equal to, we just did 0. Now we need to do 1, 4, and 9. So if I want to get this to 1, what minus 2 gives me 1? Well, that would be 3. So now I've got 4, and then I've got the square root of 1 minus 1. So 4 times 1, because the square root of 1 is 1, is 4. Minus 1 is 3. So my next ordered pair is 3, 3. I can go ahead and graph that over 3 up 3. Again, you're going to see a huge jump here because we're multiplying it by 4, so it's 4 times larger. All right, so the next number I want to get to is 4. How do I get the inside to 4? So that's going to be actually a 6 because I'm going to do 4, and then 6 minus 2 is the square root of 4, which is what I want. And then that's going to be minus 1. So 4 times the square root of 4, which is 2, is 8, minus 1, which is 7. So 6, 7 is my next ordered pair. And that goes way up here. And then finally I want to get it to 9. So that would be 11, because 11 minus 2 is 9. So it's going to be 4 times the square root of 9 minus 1. And that is going to be 4 times 3 minus 1, which is 12, and then 11. 11, 11, which I can't graph on this graph. But I can go this way. Okay, let's talk domain and range. Since it's all positive, I'm going to have x is greater than or equal to and y is greater than or equal to. I'm going to use my vertex to help me out, the 2 and the negative 1. Remember, if this were negative, it would be going down. The only other thing that I think that we need to talk about is making sure that you're writing out all your work, because this is kind of a confusing concept to get in your head. And so once you have this graph, you should be good to go. Oh, one more thing. These don't have to be perfect squares. You could get the square root of 15, and you could get a decimal. But when you're graphing it, it's not very easy to graph a decimal. You'll end up with something like right on here, but it's not always perfect, and it's not always right. So that's why we try to get to those perfect squares. Okay, so remember, tomorrow and Friday is going to be a review days. Friday, you will have a review sheet that you're going to need to complete. And then on Monday, you will have your test. Good luck.